Ramone's House of Math. What do you mean there's nowhere else to put it? Keep going. Just keep fooling around with it. I've got all the time in the world. You're going to put them underneath. You can't put them underneath. Got to get rid of those two pesky green ones.
Oh, I know. I figured it out. Put them.
Oh, yeah, see, that's not a rectangle. Can't have any open spaces. I like it though. That's some creative thinking right there. I like it, but that's not a rectangle. Keep going. Ooh. Yeah, you're not gonna get a rectangle like that. You can make a robot. I like it. Still not a rectangle. Can't put them on top. We've got some simple rules. They all have to be on the thing, all on the tabletop. All right, keep going. Yeah, you see your brain's working today.
So 10 times 10 is 100.
Wait a minute. Yeah, there you go. Yeah, I like it. Get rid of that other one. And what does it say? It says 1x squared, 3x and 2. You can only use 1x squared, 3x and 2. You got to use your mind. And see, it's like a puzzle. All right, so far so good. You need to put in the other ones. You got x squared and 2. Oh, see? Now, okay, now here's the thing. Oh, I like it. Keep thinking. Is that a rectangle? See, and this is a beautiful thing about this. You'll know when you got it because that's not a rectangle. I like it. That's like a football field.
Keep thinking. You can do it. It's easy. You can do it.
Then what? Oh. There it is. Is that a rectangle? That's totally a rectangle. Okay, so you gotta wait. I'm gonna draw wait a second. I'm gonna draw your rectangle. You made your rectangle like that. I didn't tell you how. I just said make a rectangle. Did you get it? You got it. So you did one over here, and one over here, and one over here, and you have a rectangle. So now here's the second. Get rid of that one. Now here's all I'm going to tell you. Is take your rectangle, get rid of that rectangle right there. Get rid of that block right there. Get back to the other two. Quit fooling around. Get your two green ones. And I'm just going to tell you, build it like this. Take this piece right here, those two over here. See that? And just move them over here like this.
We're making 11s.
We're making, okay, but we're in X. We're in base X. We don't know. That's why I was saying I would rather you have the Mortensen blocks, but it's okay.
Yeah, because I know everything with these.
All right, so you're fine. Put that guy there. And okay, oh wait, so you put 2 on top, right? Okay, you can have 2 on the side. It doesn't matter. Do you still have a rectangle? Yes. All right, so wait. So look, I'm going to draw it the other way. I'll put this piece over here like this. Do you still have a rectangle? Still have a rectangle, don't you? All right, now that doesn't make a rectangle. All right, so now we're going to count it. What you've done is you built a rectangle and you factored it. Put your 2 in there. And by the way, you could use this piece too, right? Okay. All right.
This is
I like it. That's another way to do it. But the easier way to do it, because we have a uniform methodology, not everybody doing their own thing, put them over here in the top corner like that, the way you had it. But you're correct. You can definitely build it the way you just did. I like your creative thinking. All right, now we got to count it. So here's what we're going to do.
132.
Can you see again? Okay, if it's 10, it is 132, but it's not 10. Those are x's. So what we're going to do is we're going to factor this polynomial. What I have is x squared, 3x, and 2. This is my x squared. This is x. And these are still units. Now what we did is we took x squared, 3x, and 2, and we turned it into a rectangle, right?
Yeah, you it. You got it right. You got it right. You made a rectangle. Yay!
And like I said, doesn't matter how you build it when you first start off, but after this, we're going to build it in a very certain way, and you are going to build a whole bunch more rectangles. But first, we're going to count this one. All right, are you ready? If you look at the one side, can you see that the one side is x plus 1? Oh, wait, yours is x plus 2 going across. So if I go across yours, because you've got it built like this, I have x plus 2. You see going across here, it's x plus 2? Right? All right. Put your rectangle back together, you.
This is a rectangle.
That is a rectangle. That's just 3x, though. I want all of it together at once. So x squared, 3x and 2, put it back the way I had it a second ago. See, and when you put them up like that, you get confused if they're 10s or if they're x's. We're just going to say that they are x because they're on the smooth side. All right. So can you see that the one side is x plus 2?
Yeah.
All right. What's the other side going this way?
X plus 2.
This way it's x plus 2. What is it this way?
X plus 1.
Very good. That's it. That's all we're doing. Are you ready for your next problem?
Yeah.
All right. We're just going to get a little bit bigger. Now, same kind of rectangle. Use two sides, just like you did. And now I want x squared, 4x, and 3. Your problem, should you choose to accept it, and you don't really have a choice, is to make x squared, 4x, and 3 into a rectangle. There you go. Now you need another unit. Oh, look, you did a pink one. I like it. So you did it 3 by itself. Tell me the factors fast. Going across, it's what? X plus what?
X plus 3.
And what's it the other way?
X plus 1.
X plus 1 still, right? And you can see anywhere along there it's x plus 1. We'll get to that in a minute. All right. Now I'm going to give you a harder one. Oh, look at that. His brain. I like it. You used a lot of calories figuring out that first rectangle. All right. Go get a glass of water. Have you got a glass of water right there? Good.
It's empty.
Put some water in it and drink it. All right, he's back. All right, drink it up. It's good for your brain. You got to be hydrated when you do math. All righty, good stuff. You drank it all. All right, now I'm going to give you a toughie. You ready? X squared, 5x, and 6.
You could do it. You could do it. You can do it. X squared, 5x, 6. Stick it in a rectangle.
You want a hint?
Nope.
Okay, no hints for you. All right, no hints for you. But you can only use 5x. You can only use 5x. Can't put another one in there. I know what you're trying to do. You can only use 5x. So you sure you don't want a hint?
Wait, let me see.
You got to make a space for them to fit in the corner.
Wait.
Come on, let me give you a hint. I just want to give you a little hint. One hint.
All right. Here's your hint. Yeah, see, it's always going to be sticking out, right? So here's your hint. If you try to use this block right here, you're going to have a bad day. So how else can you make 6? Fibber McGee's closet down there. Alrighty. Oh, don't use all of those. That's going to be terrible. Don't use those. How else can you make 6?
So this
How
is
else
how
could you make 6? How else could you make 6 besides just
3
this?
things.
Okay, I'll tell you. Do this.
Wait, I think I got
Wait,
it.
I'm gonna tell you. Do this.
What? Wait,
All right.
can I just try this quickly?
All right, try it, sure. Now tell me the difference between a straight line with 6 and a straight line with units. It's the same thing. And you're still going to have that one pesky unit sticking out, aren't you? Yeah. Oh, yeah, starting to make sense. I told you, just use 2 sides. That's 3 sides. Just use 2 sides. Oh. Just use 3. Just use 2 sides.
Yeah, that's
Put your blue ones together. Only use 2 sides, not 3. There you go. Bam. Can you see where the 6 is going to fit?
yeah.
All right, get rid of the green ones. It takes too long with the green ones.
But I like green.
Takes too long with the green ones. Get rid of the green ones. That's why we have them stuck together. This is why we don't use Unifix cubes and all these other ones, because it takes forever. And we got math to do, man.
Math is.
All right, so give me 2. Get those guys out of there and give me 2 of those guys. I like it with the green ones, but we don't have that kind of time.
You said we have all the time in the world.
Yeah, you had all the time in the world to figure out the first one, but after this, we want to move. We want to get snapping. All right, get that other one in there. All right, now your job once again. Tell me the factors.
It's x
Mm-hmm.
6.
Where do you see x plus 6? That would be x plus. That would be x plus 6.
5.
X plus how many? All right. Go get a piece of paper from the copy machine. Just one sheet of paper. Or that right there. All right. Put it across the top so you can only see x plus 3.
Can't
Not,
see anything.
don't just cover it, but just put it so you can see that one side is. Slide it down. Well, go the other way. This is when not being there is frustrating because I'd be done. All right. Slide it over a little more. A little more. Just so that 1 is showing. 1x and what? 2, right? Slide it over a little bit more. All right. X plus 2 is the one factor. What's the other factor? Slide it the other way. So that the other side is showing. So that you, all right, look, you. First, I want to show, oh, what? And now I don't have a piece of paper? All right. Here. What do you got? Interesting. Anyway, pay attention. Look, first I want you to show it like this, where you have x plus how many? I see you broke up your thing. Oh, dude. We'll wait. All right. Now, show it where you just show the top. Just like that. Perfect. What is that side? And just 1. I just want to see 1. I don't want to see the whole thing. Just 1. So what is that? That's x plus 3, right?
Yeah.
Now, what's the other factor? That side's x plus 3. What's the other factor? What's the other side?
X.
Plus what?
3.
One side's x plus 3, but the other side isn't x plus 3. Look, I'll draw a picture again. Here is your x squared.
2x.
Ah, there you go. See? See, we're only counting the one side. Because from here to here, it's x. From there to there, it's x. From there to there, it's x. From here to here, it's x. X. Did you build it like that? Do you have 2 on the side or 3 on the side?
2.
Okay, so you got 3 over here on top. Right? Okay. Now, can you see? 1, 2, 3, 1, 2, 3. Can you see that from here to here, it's x plus 3? And from here to here, it's x plus 2? But look, anywhere along here, from here to here, it's x plus 3. From here to here, it's x plus 2. Are you paying attention? All right. So what are my factors? The across is x plus 3. The up is x plus 2. That and that. We're making rectangles and we're counting the sides.
Not triangles.
Not triangles. Rectangles. What's that shape in front of you? What's that shape in front of you?
A rectangle.
All right. Time to build another. Time to build another one. You want a hard one or an easy one?
Hard.
All right. I like it. Right off the bat.
What is
All right. I'm going to give you x squared, 7x, and 12. You're on. Put that other stuff away. And your pencil. You don't need that. X squared. You need 7x and 12. We got 7x. Wait a minute, you got, okay, now you got 7x. And there is the case for multi-tens right there. But anyway, all right, go, build it. You got to be able to fit 12 in the corner now.
That's easy.
All right, let's see it. I like it. How about you just use these? I like it. I know what you're doing. You're thinking, how many 4s do you need to make 12? How many 4s do you need to make 12?
You can't make 12.
Yes, you can.
It goes 12.
It goes 4. And then what? 8.
8.
And then what? And then what?
Oh, I thought it would count.
Oh, 4, 8, oh. No, wait. 4, how's it go?
12.
4, 8, 12. Put them in there and hurry up.
Then 16.
Well, if you have another one, but we don't need another one. What does it say? It says x squared, 7x, and 12. You want to do one with 16 in there?
No, let's do one with 1.
We do x squared, 2x, and 1, but that's so boring. Tell me the factors first. Be fast. Tell me the factors.
What's a factor again?
Oh, excellent question. I like that. A factor is one side of the rectangle.
One side is 3.
X plus 3. Where do you see 3x? 3x, if you were counting the side of a rectangle, 3x would be like this.
3x is right here.
You are correct. But the distance from here to here is not 3x. The distance from here to here is x. Ooh, look at his brain working. Look at his brain working. All right. The distance across this way is 3. So just look at this. Let's just examine this for a second. Across it's 3. Up, we don't know. It's x. And you're right. If x is 10, it's 30. But with x, do we know how much an x is? We don't know how much an x is. That's why we use x. We don't know. Could be 5, could be 50. You got to use your imagination. Could be 100. Could be 0.5. We don't know how much an x is.
X is 0.
X could be 0.
Like, can I just say x is 0?
Not every time. Right? Now, if we look at this right here, this is 3 going across here, but it's x going this way. Right? Now, oh wait, let's spend some time on this one. This is x squared. It's x this way, and it's x this way. Right? It's not 3x across. It's just x.
Well, actually, it's not x because you can see.
Oh, yeah, I know. See, that's why. That's why I wanted to use Mortensen math blocks instead of math UC. Because on this side, that's 100. You're right.
Wait,
but we don't know. See, that's why. We on this side, we don't know. Right?
Yeah, I can see that.
Okay. On this side, it's smooth. And we don't know how much it is.
On mine, I don't see that.
Right. Well, because you got a different block.
This is 100.
That is an x square. This is 100. This is an x square. What does that mean? It means we don't know how big it is.
Wait, so yours isn't hollow?
No, mine isn't hollow. Mine is solid. I don't think I even have any hollow ones here.
You bought me. Mine is hollow.
I know. I can see that. Just use the one side like this and put it back down there in your rectangle, because we're still counting it. What are the sides? So far we figured out that. Well, actually, you still haven't told me what the sides are. Tell me what the sides are.
4
x plus
12.
Do we have 12? Are they like this? Can you count them like this? That would be a 12. What you have there on this one, what are the factors of this?
It is 12.
The whole thing is 12. The whole rectangle is 12. What did I tell you what factor meant? What does the word factor mean? It means the distance across and the distance up. The two sides of your rectangle. So the factors of this are the factors of 12 are 3 and 4. Well, that would be 3 and 4. This would be 4 and 3. Across it's 4, up it's 3. Oop. Across it's 3, up it's 4. Those are the factors. Right? I wouldn't call this 6 because it's only 3. I wouldn't call this 8. I wouldn't call this 12. Now, the factors are 1 by 12. Make sense?
Yeah.
All right. Tell me the factors of your rectangle one more time. X plus what?
X plus 3.
Mm-hmm.
And X 3.
X plus 3. And the other factor is?
X plus 3.
Are they both x plus 3?
No.
What's the other factor?
4.
X plus 4.
And 4.
All right. I'll give you one. Okay. All right. So it's x plus 3 across, and it's x plus 4 up. Make sense? All right. I'm going to change it. I'm going to give x squared 7x, but now I only want to fit 10 in there. So get rid of your 12. Same amount of x, but you can only fit 10.
Okay. That's kind of easy.
I think so too. How are you going to get 10 in there? I like it. Good job.
Yay, got it right, yay! Yay! X plus, yay! You got it.
Tell me the factors.
On the side, it's
The going across is
5x. And the top
Wait.
is
wait. What's it going across? It's what?
5x.
Where do you see 5x? Again, if you had 5x, they'd all be in a row like this. Right? Okay. Now you've got 5x like this. Right?
Yeah.
But look, even if I only did this much, here are my factors. Look. I'm just gonna do this part. I need some Play-Doh badly. Next week we'll have Play-Doh.
You should
And
get
I'll be able to stick it on the wall. I'll be able to stick it on the board, I mean.
putty. You should get magnetic putty.
I like your magnetic putty idea, but I'm just going to use Play-Doh. Look, x plus 2 by 5. It's 5 across and x plus 2 up. Now if I change it like this, now it's x plus 2 by 5. Right?
Yeah.
All right. So tell me the factors of your rectangle one more time. You've got 8 on your head.
X plus.
Going across. X plus how many? Take your finger and run it. Get your fingers off the top of your head and take your finger and run it across the top of your rectangle. From left to right. From left to right.
X.
From left to right. Start at the top and go from left to right. Okay, so you went across X, and then you go across how many more? Put your finger down and just run it along the thing. Just like this. What's the problem? X the other way, left to right. Your left to right.
This is my.
Okay, so start off at the left and go over to the right. X plus how many? X plus 5. How many is it up?
X.
Put your finger on the bottom corner over there on the bottom right hand corner. Bottom right hand corner. On the outside. Down there in the corner. Look, you've got a rectangle. Start over here. Put your finger right there. Oh, except on the other side. All the way. Yep. Okay, now go up. How far up do you go? X plus how many?
X 10.
Is there 10 there? Can you go like this? Can you count that like that? Is that X and 10 more? Or is it just X and 2 more?
5x. Or 10x.
Where do you see 10x?
I mean 5x.
Where do you see 5x? That's the whole thing.
Wait.
Again, if I have all these guys like this, and I'm making a rectangle.
Isn't it time?
Is it time? Is it time? It is time. Look, we just did algebra today. All right, but we had some mess ups with the thing. But look, if I go this way, I have 5, 10, 15, 20, 25, 30. Can I say that this side is 30 right there?
6x.
All right. It's just 6. Are there any x's?
No. I mean,
What is it this way? What is it this way? If I go across this way, what is it?
5.
Well, if I'm going to be like you, I'd say that's 30. It's not 30, it's 5. You're right. And if I go up, how far is it?
X.
Wait a minute. Can I count that? I can count that. 1, 2, 3, 4, 5, 6. Do I have any of these?
Yes.
So how are you counting X here? 1, 2, 3, 4, 5, 6. And what's this distance?
5,
So 5 times 6. What's the whole thing? The product?
30.
30. The whole rectangle is 30. One side isn't 30. The factors are 5 by 6. Now the
11.
factors in your rectangle over there are x plus 5 and x plus 2.
Okay.
All right, we're going to come back to it next week.
Okay.
Okay? And you're doing quote unquote high school algebra for the 17 plus crowd. Your brother was having a hard time with this when he was in
You
college.
mean May?
What's that?
May? You Mandela?
No. What do you call? Narie.
You only did it with him once. Didn't you
No,
do
I
it
did it with him
my
way
other
more than
brothers?
I did it way more than one time with him.
Like, didn't you do with another one of my brothers?
No, I think only you and Narie.
Yeah, Mom says you did it with May, and you only see Nera in the background.
I don't know.
May is Mandela.
Okay. Anyway, next week, have your tablet charged, have your blocks ready, and we'll do more algebra. What do you say?
She just so you know, she's in college. She got a B without even doing anything.
Well, that's good. All right, I gotta go because I got another class and they're waiting for me.
Bye.
All right, I'll see you later. Crewton Ramone's House of Math.com for more.